So for example number 5, what they want us to do is they want us to find the limit, and this is kind of funny, they want us to find the limit of tangent of x equals negative infinity, but they don't know what causes that. From the right hand side, and the limit as x approaches some value from the left hand side. So this is different. Now they're telling us what they want the limit to be. But they're not telling us what the x value is. So these are basically vertical asymptotes is when this occurs, right? Whenever a limit approaches either infinity or negative infinity, it approaches at a vertical asymptote. So the vertical asymptotes, as we just said in the last example, occur when what? Yeah, when the denominator is 0. Well, then we got to look at tangent of x. What is tangent of x? I made a fancy video on it. Sine over cosine. So what are we really interested in? When does cosine equal 0? Let's look and see. Well, cosine equals 0. Let's graph it. I mean, we should know the answer, but let's graph it and look at the graph, and then we'll go from there. So we have a 0 here. Does anybody know off the top of their head what that 0 value is? Okay, so what we want to know, cosine of something equals 0. Right, so what is that something? Quick reminder, we don't need the calculator. Let's put the calculator away. You guys need to know this off the top of your head. Boom! What is this?
That's a graph.
That is it. This is the unit circle. And it's always going to be cosine, comma, sine. This point here is 1, comma 0. This point here is 0, comma 1. This point here is negative 1, comma 0. This point here is 0, comma negative 1. So cosine is 0 when this is 0, this is pi over 2, this is pi, this is 3 pi over 2. When are the x values equal to 0? Pi over 2, 3 pi over 2. If you were to come around again, what would it be again? 5 pi over 2. Thank you, gentlemen. So, and we could go in the other direction, right? So it's any integer. It's any integer times. How would I write that? You go in the other direction too.
Okay.
What do we call these? Odd numbers, right? So could we say 2k minus 1 times pi over 2, where k is an integer?
Yeah.
Because if I plugged in negative 1, I get negative 2 minus 1 is negative 3 times pi over 2. That's it.
Where do you get the k from?
Now, if we go from one direction, and so basically, where do I get the k from? That's the formula for an odd number. 2k is always an even number, right? Because even numbers are multiples of 2. 2k minus 1 is an odd number. You can put a plus 1, I guess, if you wanted to. It doesn't matter. All right, so what does that mean? That means that I have a vertical asymptote at some odd multiple of pi over 2.
Yep. Wait, sorry, where'd you get the 9 from?
The 9,
That's an A.
that's an A.
Oh,
That's the value of A. So if I graph this, tangent of x, we'll see that we have a vertical asymptote that occurs at, pick out any odd integer times pi over 2.
3.
Negative 3, all right, great. So if I come in here and I graph this, and I hit trace, and then I say negative 3 times pi divided by 2, it's not defined. If I trace just a little bit to the left of that, in other words, if I'm coming in from positive infinity, it is approaching negative infinity, right? If I go in the other direction, on the other side of that, and in other words, if I approach pi over 2 from the left-hand side, my y value increases significantly and blows up to infinity. Does that make sense? You guys got this? Get it good?